Okay, this is the P3 paper from June 2023. It's question number 4. And as we can see by looking at this is a functions and graphs questions. And in particular, we're going to be looking at inverse functions. So let's have a look at part A. Part A says, function fx is defined by 2x squared minus 5. Can we state the range of this function? Well, it's very straightforward, but I'll just say what I normally say to my students, which is, if I want to find the range of a function, if you can sketch it, then do that. That'll really help us. So if fx is equal to 2x squared minus 5, we know, or we should know, exactly what that looks like. Okay, if we've got our graph here, sorry, we've got our axes that looks like that, I would expect everybody to know what y equals 2x squared looks like. Okay, that's the function y equals 2x squared. And if I'm going to do the function y equals 2x squared minus 5, then all that's going to happen is that we're going to get that as our graph. What's the domain? X is greater than or equal to 0. So we're talking about that being our function, which means that if I want the range of fx is just fx is greater than or equal to minus 5. So only one mark for that, and fair enough, that's a very, very straightforward part A. Part B, then it says, on the diagram 1, there's a diagram just a little bit lower down, sketch the graph of y equals f to the minus 1x. So here's B, and it's saying, if there's fx, can we sketch f to the minus 1x? And what we want to do basically is to understand that if I put the line y equals x in there, if this was the line y equals x, then the inverse will simply be a reflection about that line. So obviously whatever this point here is, we're going to start over there somewhere. And then let's try and draw this. And we would get something like that as being the inverse function, y equals f to the minus 1x. Did they ask us to put anything up? No, they haven't said about any specific points on there. They hadn't put that on as minus 5, but you could, if you want to, put minus 5 and minus 5 on, but you absolutely do not need to do that. And then part C says, the curve y equals fx meets the curve y equals f to the minus 1x at P. Can we find the exact value of the x coordinate of P? Right, okay, so we're trying to find this point here, or rather we're trying to find the x value for that. So for part C, it would be where f to the minus 1x equals fx, but that's not the way that we actually do this. You should have seen this throughout our studies of functions, that those 2 points also meet, as I've said on the diagram, where y equals x. So rather than subbing f to the minus 1x equal to fx, you'll often get quite complicated equations there. Rather than doing that, I'll do fx equals x, and that'll be much easier to do. So fx was 2x squared minus 5, and I want to find out where that equals x. So that's now just a matter of solving that. So if we're solving that, that's 2x squared minus x minus 5 equals 0, which is going to give me x equals, it doesn't factorize, so put it into the quadratic formula, minus b, which is 1, plus or minus square root of b squared minus 4ac, which is minus 4 times 2, luckily times minus 5 there, all over 2a, so all over 4. Perhaps improve the handwriting of that. All over 4, and then I'll just give you the answers there. So that works out to be 1 plus or minus root 41 over 4. And then actually, because I can see the value for x is positive, it's 1 plus root 41 over 4, not 1 minus root 41 over 4. So that's the final answer for the exact value, x value where f to the minus 1x equals fx, and hopefully that'll